So my name is Professor Kim Hemsley. I'm the head of the Childhood Dementia Research Group at Flinders University in South Australia. I'm also the neuroscience lead for the Flinders Health and Medical Research Institute at Flinders University. I'm proud to have had a public school education in Australia. At high school, I wanted to become a doctor after leaving school, but I had a really fortunate interaction with a teacher who guided me towards an applied science degree at the University of South Australia. And I'm so grateful for that career counselling, because it started me on the path to where I am today. I then worked as a research assistant, so a research scientist in a lab, and was again luckily mentored by my then lab head, Emeritus Professor Anne Crocker here at Flinders University, mentored to undertake a PhD in neuroscience. After that, I moved on to a postdoctoral scientist role at the Women's and Children's Hospital here in Adelaide, where I was able to use my neuroscience knowledge and skills and establish my current research group. And our goal was then, and still is, to understand the way disease develops in and to devise treatments for children who have an inherited disorder of metabolism that leads to dementia. Our research focuses on a group of disorders that were first described by a paediatrician in Minnesota in the US. His name was Sylvester Sanfilippo, and he and his colleagues described the symptoms that are experienced by children in their first few years of life. And this group of disorders is called Sanfilippo syndrome. And many people won't have heard of it because it is a rare set of conditions. It's inherited, and children start to go through their normal developmental milestones, so things like learning their first words and first sentences and beginning to move around, but then their development stops or slows. And unfortunately, it actually then starts to go backwards. So those skills that the children have developed are lost. So it's actually a little bit like a childhood onset form of Alzheimer's. It most commonly affects speech and the way the child thinks, but also sleeping patterns. Children can have epileptic fits. It's truly a devastating disorder. And sadly, the disease is a terminal one. In the rapidly progressing form of Sanfilippo, sees children die commonly in their late teens, so 17, 18 years of age. And the worst thing about this is that at the moment there's no treatment. No approved treatment, no safe treatment. So the children only have their symptoms managed. So things like trying to help them sleep better. So the goal of our work, of course, is to develop and to come up with novel strategies that can potentially be advanced into the clinic and can give these patients what we hope is a normal quality and quantity of life. To do this, we use cell models that come from patients and also mouse models of Sanfilippo syndrome. We can't work on this in isolation. It's very important that we interact with the doctors working with the patients themselves and other scientists, chemists and other neuroscientists, in order to advance our work in the fastest possible way. So we work with people around Adelaide, around Australia, and also from overseas. And that teamwork is really essential to getting treatment for Sanfilippo syndrome in the fastest possible way. My passion, and I believe my group's passion, comes from the unmet need. The fact that children with Sanfilippo syndrome have no recourse, there is no treatment for them. And I guess because Sanfilippo is such a rare disease, it affects around about 1 in 100,000 children, each of the different types of Sanfilippo syndrome. Overall, it's around about 1 in 60 to 70,000. Because it's such a rare disease, it probably hasn't had the attention that it deserves. And this is true for rare diseases across the board. So it drives me every day to work for these families, work for the children, and to come up with a treatment that we hope in the next few years can advance to testing in patients. What we're hoping to do is to at least slow the disease in its rapid progression, but preferably stop it, or ideally, if we're able to test for this disease at birth, we would intervene before the child even develops their symptoms, because that will give us the best possible outcome in patients. Working in this field is particularly special for a scientist, a lab-based scientist like myself, because most scientists don't get to actually work with the families for whom they're doing their science. So we interact with the families and the children on a regular basis, and that's a true driver for us. It has linked us up with the people for whom we come to work each day. We know and care about them, and it makes us work all the harder and all the faster. That is really what I guess drives my passion in my work. When I'm not in the lab, I like bushwalking, going out for a run every now and again, doing some reading, non-science reading, and I've recently developed a passion for some more artistic endeavours. I'm not very good at it, but I do like having a go at painting and collage, and probably not to the delight of my neighbours, I've taken up the ukulele.